Okay, so the next part that we have in this chapter is miscellaneous exercises on chapter 2. If you need the solutions, you can go to basically you can go to the tiwariacademy.com. You can go to the tiwariacademy.com. You can see the address over here, and then here you have the solutions for class 6 to 11, and then you can go for class 12. I said class 11, I meant 12, and class 12 mathematics, and then you have basically all of these chapters, inverse trigonometric functions. And then you have basically miscellaneous exercise 2. Miscellaneous exercise 2, chapter 2, miscellaneous exercise 2 solutions. And then if you can get that in PDF. And then here you have basically, here you have 17 exercises. And here you have exactly 17 exercises. So most of the time they are really helpful. Okay, so now let's get started. You want to find the value of the following trigonometric functions. And so you have basically question number 1. You have the cos inverse of cos of 13 pi by 6. The cos of 13 pi by 6. Now 13 pi by 6 is some angle. Basically pi by 6 is 30 degrees. So 30 degrees would be this angle over here. So you have 1, 2, and 3 pi by 6. You have 3 pi by 6, so that is basically pi by 2. So 4, 5, 6 pi by 6, 7, 8, 9 pi by 6. 9 pi by 6 is divided by 3, you will get 3. Divide by 3, you will get 2. 3 pi by 2. So that is 9 pi by 6. 9 pi by 6, and you have basically you have 10, 11, and that is 12 pi by 6. 12 pi by 6 is the same thing as 2 pi. Now 13 pi by 6 is, you come back again to this angle here, which means that it's actually 360 plus 30, which is equal to, in degrees of course, which is equal to 390 degrees. 390 degrees. So of course it's out of the domain of the cos inverse function, because the domain of the cos inverse function, as far as we know, is negative 1 to 1. Is negative 1 to 1. No, I'm sorry, the cos function is 0 to pi. So we have exceeded the domain of the cos function. So we have to rewrite this angle in terms of the angles that the formulas that we had before. Okay? Now, the way that you can do that is that, of course, you can write it as basically cos of, based on what we saw here, you can write it as the cos of, so you can write the cos of 13 pi by 6. 13 pi by 6, you can write it as the cos of pi by 6. That you can do. Now, based on the formulas that we have, we can use 2 pi. So if I write the cos of 2 pi minus x, so I'm going to get a cos over here. The trigonometric ratio is not going to change because I'm dealing with 2 pi. The only way that the trigonometric ratio can change is if you have pi by 2, meaning pi by 2 minus x or pi by 2 plus x. And so since I'm not dealing with these, so then cos remains cos. And then basically what happens is that basically we said that the mnemonic that we memorized there was AS, ST, and CX, I suppose, if I'm not mistaken. Let me take a look at those. The mnemonic that we had to memorize was ASSTCX, right? So ASSTCX, and this is basically this case over here, which means that only the cos does not change in this case, meaning that out of all of those 6 trigonometric ratios that we have, only the cos does not change, meaning that positive remains positive. Otherwise, all the other trigonometric ratios will change. So I can simply write this as positive cos x. And now if you take a look at the formulas your formulas, you can see that the cos of 2x is equal to cos x, and the reciprocal of that, which is secant also does not change either. Secant remains secant, positive secant, but all the other trigonometric ratios actually do change. Which brings us to the fact that basically cos of 2 pi minus x is equal to cos x, right? So now I can use this, most probably will give me some angle that I can use here in the range of the cos inverse function, which is 0 to in the domain of the cos function, which is 0 to pi. So what that means is that now if I basically based on this formula, cos of x is equal to the cos of 13 pi by 6, which is based on this formula equal to the cos of 2 pi minus 13 pi by 6. Now, basically, what is 2 pi minus 13 pi by 6? That is equal to 6. 6, that is 12 pi minus 13 pi, right? So that is equal to 12 pi minus 13 pi is equal to negative pi by 6. Negative pi by 6. So that means that the cos of 13 pi by 6 is equal to the cos of negative pi by 6. And of course, you know that the cos of negative pi by 6 is equal to cos of pi by 6. So you can of course write it as the cos of negative pi by 6, or you can write it as the cos of pi by 6. This is also equal to the cos of negative pi by 6. And of course, you know that the cos of negative pi by 6 and pi by 6 are actually the same values, because if you take a look at this, if this is pi by 6 and if this is negative pi by 6, then of course the cos of both of these angles is going to be this length on the unit circle, which is actually the same thing. So what that means is that now I'm going to, since basically the range of the cos function is 0 to pi, and I don't really know if it's basically the closed interval or what. is 0 to pi, the closed interval 0 to pi. So what that means is that of course negative pi by 6 I cannot take it, because the domain of the cos function starts at 0 and goes to pi. So I have to write it as the cos of basically pi by 6. The cos of pi by 6, or I have to write this as the cos inverse of cos of pi by 6, and that is equal to pi by 6. That is equal to pi by 6. Now you can, of course, you add to your formulas the trigonometric ratios related to. So far what we have done is that we have taken basically, let's add to those formulas a little bit, so that 265 if I delete this layer. Yeah, so far what we have done is that we have all the trigonometric ratios related to pi by 2 minus x. We have pi by 2 plus x. We have basically pi minus x. We have pi plus x. For 3 pi by 2 we have not done anything. It seems that it's really not required. I've never seen the trigonometric ratios of pi by 2 anywhere. For 2 pi we have done basically 2 pi minus x, but 2 pi plus x we have not done. So we can actually do this. Now to do this, let's start with basically the sine of basically 2 pi plus x and the cos of 2 pi plus x, and then based on that we can derive all the other trigonometric ratios. And you know that basically the sine of x plus y is equal to sine x cos y minus cos x sine y. And you know that the cos of x plus y is equal to cos x cos y, and that is actually positive, sine x cos y plus cos x sine y. And this is minus sine x sine y. And so the sine of 2 pi plus x is equal to sine 2 pi cos x sine 2 pi cos x plus cos 2 pi basically sine x. Now sine 2 pi is equal to 0. So this whole thing goes to 0. It's the same thing as sine of 0, so this whole thing is 0. And cos of 2 pi is equal to 1, so this becomes sine x. And cos of 2 pi plus x is equal to cos 2 pi cos x minus sine 2 pi sine x. So that is equal to, so cos of 2 pi is equal to, cos of 2 pi is equal to 1, so this becomes cos x, and sine of 2 pi is equal to 0, which means that sine of 2 pi plus x is equal to sine x, and cos of 2 pi plus x is equal to cos x. So these are two things that we can use for the rest of those formulas. And sine and cos. So now tan of 2 pi plus x is equal to basically sine of 2 pi plus x over the cos of 2 pi plus x, which is equal to basically sine x over cos x is equal to tan x. And cot of 2 pi plus x is equal to the cos of 2 pi plus x over the sine of 2 pi plus x, which is equal to cot of basically cos of 2 pi plus x is equal to cos x, and that is equal to sine x, that is equal to cot x. Now the secant 2 pi plus x is equal to 1 over cos of 2 pi plus x, which is equal to 1 over cos x, which is equal to secant x. And cosecant 2 pi plus x is equal to, and cosecant 2 pi plus x is equal to 1 over sine 2 pi plus x, which is equal to 1 over sine x, which is equal to cosecant x, right? Which means that we can make a screenshot here and put this over here and rewrite these as the sine of 2 pi plus x is equal to sine x, and the cos of 2 pi plus x is equal to cos x, and tan of, let me see how I have written the rest of these formulas. I want to write them in the same way. Sine, cos, tan, cot. Okay. So now tan of 2 pi plus x is equal to tan x, and cot of 2 pi plus x is equal to cot x. Secant of 2 pi plus x is equal to secant x, and cosecant of 2 pi plus x is equal to cosecant x. So now we can basically make a screenshot here and add these to our formulas as well, meaning that let me take a look at the formulas that we have. So trigonometric identities part 8. So I'm going to make a screenshot here, and I'm going to call this on desktop, I'm going to call it trigonometric identities part 9. And we have to make some changes to this table as well. So I'm going to open this with Paint, for example, and as you can see, basically basically this part is 2 pi plus x is 2 pi plus x. So we have added that now, and basically the not sign change happens in the case of all of those trigonometric ratios, as you can see here. As you can see here, that the not sign change happens in the case of all of these, because all of these trigonometric ratios are positive and all of these are positive, which means that the not sign change happens in the case of all of these trigonometric ratios. So I can write here A, and the trigonometric ratio simply does not happen. The change in the trigonometric ratio does not happen. So that means that the only place where we have the change in the trigonometric ratio is in the case of pi by 2. In the case of the rest of them, it doesn't happen. And now the mnemonic that we have is ASST. Instead of CX, it becomes CA. That's the only change that we have made here. And then we can save this now. Okay. And the changes have been saved. And now we can go back to what we were doing before. So now going back to the problem that we had, we can actually use these formulas that we just derived, meaning that basically the cos inverse of cos of 13 pi by 6, instead of using the cos of basically 2 pi minus x, which is equal to cos x, I can write the cos of 2 pi plus x, which is equal to, because as you can remember, when I used the cos of 2 pi minus x, in order to write the cos of 13 pi by 6, I had the cos of 13 pi by 6, the cos of that, and I used this formula and I wrote it as the cos of 2 pi minus 13 pi by 6. 13 pi by 6. Now, 2 pi minus 13 pi by 6 was negative pi by 6. 2 pi minus 13 pi by 6 is equal to 6, so that is 12 pi minus 13 pi, which is equal to negative pi by 6. Negative pi by 6, which is not still in the domain of the cos function, because the domain of the cos function goes from 0 to pi, right? Now, in order to get that, and well, that we had to write that as the cos of basically negative pi by 6, and since we know that the cos of negative x is equal to cos x, then we wrote that as the cos of pi by 6, and the problem was solved. But now, instead of going through all of these steps, what you can do is that you can actually use this formula here, meaning that instead of using this formula, you can use the cos of 2 pi plus x, which is equal to cos x, and write this as write the cos of 13 pi by 6 as basically the cos of 2 pi plus 13 pi by 6. Cos of 2 pi plus 13 pi by 6, which gives you now 2 pi plus 13 pi by 6 is equal to 12 pi. or they have actually used this formula in a slightly different way, because if I write the cos of 2 pi plus 13 pi by 6, it's going to give me basically plus 13 pi, and that's going to be 25 pi by 6, and I'm still out of the domain of the cos function. So since I know that basically 13 pi by 6, we saw the angle was coterminal with a pi by 6 radian angle, and this is again the same thing as 13 pi by 6 as well. So I can say that, of course, I can say that basically the angle 13 pi by 6 is equal to pi by 6, meaning that the cos of 13 pi by 6, I can write it as the cos of pi by 6, and I don't really understand what they have done here. Look, let me go over the solution. What they have done is that basically it says that given that basically the cos inverse of cos of 13 pi by 6, so we know that the cos inverse of cos x is equal to x if x belongs to 0 to pi, which is the principal value branch of, branch of cos inverse x. Therefore, the cos inverse of cos of 13 pi by 6, the cos of 13 pi by 6 is equal to the cos inverse of, now they have written the cos of 13 pi by 6 as 2 pi plus pi by 6, which makes sense, of course, because 13 pi by 6 is equal to actually 2 pi plus pi by 6, right? So the cos of 2 pi plus pi by 6, right? That you can do, of course. Now, still we haven't used any formulas. Now, we know that the cos of, based on the formulas that we just derived, the cos of 2 pi plus x is equal to the cos of x, which I can write, and based on this, I can write the cos inverse of, basically now the cos of 2 pi plus pi by 6 is equal to simply cos of pi by 6, right? And now pi by 6 is in this, belongs to this range, which means that I can write this as pi by 6. So that is basically how they have solved the problem, which is actually a good way of solving the problem. Okay, so that was question number 1. Okay, so the next example that we have here is question number 2, which is the tan inverse of 7 pi by 6. 7 pi by 6. So 7 pi by 6 is some angle over here. Is basically, if this angle is basically, if this angle is pi by 6, then this angle here becomes 7 pi by 6, because this is 6 pi by 6, which is equal to pi, and so basically this becomes 7 pi by 6. Now we know that basically we know that the tan inverse of we know that the tan inverse of 7 pi by 6 is equal to the tan inverse of tan of basically x is equal to x if x belongs to the domain of the tan function. The domain of the tan function is basically negative pi by 2 to pi by 2. Negative pi by 2 to pi by 2. Right? Which means that now negative pi by 2 is right over here, and pi by 2 is right over here. That means that you have to bring this angle back to either basically any of these two quadrants, either here or here. So in order to do that, of course, I cannot use pi by 2, because if I use pi by 2, then basically tan of 7 pi by 6 becomes cot of some other angle, which is not what I want. So I can use, for example, pi minus x, or basically pi plus x, for example. Now I know that basically the tan of pi minus x and tan of pi plus x are equal to, basically tan remains tan, and here I have x's. Now this is basically the mnemonic that we used here was ASSTCA. ASSTCA. Right? So these are basically the two cases that are related to these two cases. So here we said that only in the case of sine, the sine and cosecant, the algebraic sign does not change, meaning that the sign here changes. And here in the case of tan, it doesn't change. So that means that this becomes positive. So now since I get a negative sign here, that creates problems for me. Because if I write the tan inverse of tan of 7 pi by 6, that is going to be equal to, let's say that negative tan of, for example, x is equal to tan of pi minus x, and so that means that tan of x is equal to negative tan of pi minus x, negative tan of pi minus x, and so over here I have tan of 7 pi by 6, which is equal to negative tan of pi minus 7 pi by 6. Now what is pi minus 7 pi by 6? It's equal to 6 pi minus 7 pi, which is equal to negative pi by 6. That is the same thing as tan of basically negative tan of negative pi by 6. And well, of course you can write that as negative of negative tan of pi by 6, because tan of negative x is equal to negative tan x, and that becomes tan of pi by 6, right? That becomes tan of pi by 6. So tan of 7 pi by 6 is equal to tan of pi by 6. So I can write it as tan inverse of tan of pi by 6, and that is equal to then that is within this domain, which means that it's equal to pi by 6. It's equal to pi by 6, right? So that way you can solve the problem. Alternatively, what you can do, you can use this formula as well, most probably. Let's see what happens. If you were to use this formula, you would write this as, I know that tan of, basically I want to rewrite the tan of 7 pi by 6. The tan of 7 pi by 6, basically pi 7 pi by 6, so pi plus 7 pi by 6 is going to give me some angle over here, which is again pi by 6. Meaning that if I write tan of, since tan of x is equal to tan of pi plus x, I can write tan of basically 7 pi by 6 is equal to tan of pi plus 7 pi by 6. Tan of 7 pi plus 7 pi by 6, which is equal to, now what is pi plus 7 pi by 6? Basically pi plus 7 pi by 6 gives me 6 pi plus basically 7 pi, which is equal to 13 pi by 6. So that is equal to tan of 13 pi by 6, and of course tan of 13 pi by 6 is actually equal to tan of pi by 6, because we said that tan of basically tan of 2 pi minus x is equal to tan of so you have basically tan of 2 pi minus x is equal to tan of x, and we said that ASST CA, that means that basically over here cos, and so this changes, right? So that means that then tan of x is equal to negative tan of 2 pi minus x. That means that tan of basically 13 pi by 6, tan of 13 pi by 6 is equal to negative tan of 2 pi minus 13 pi by 6, 2 pi minus 13 pi by 6. Now 2 pi minus 13 pi by 6 is equal to 12 pi minus 13 pi, which is equal to negative pi by 6. So that is equal to negative tan of negative pi by 6. Now we know that basically the tan of negative x is equal to negative tan x, and therefore this is equal to negative tan of pi by 6, and that is equal to tan of pi by 6, right? So this is equal to again tan of pi by 6, and tan of pi by 6 here is equal to, so again I can, so basically we have now realized that tan of 7 pi by 6 is equal to tan of pi by 6 is equal to tan of pi by 6, and therefore and therefore I can write the tan inverse of tan of 7 pi by 6 is equal to the tan inverse of tan of pi by 6, and that is equal to pi by 6 because basically pi by 6 belongs to negative pi by 2 to pi by 2. And that is another way that you can solve the same problem. Okay, so you have to basically find some way in order to use the formulas that you have. Now there's a couple of things that we want to prove here. There's a couple of things that we need to prove, and question number 3, we want to prove that 2 times sine inverse of 3/5 is equal to tan inverse of 24/7. Now to show this, okay, so here basically we need to use a couple of formulas that the formulas that we had before, we cannot use them, meaning that basically the formulas that we derived here, we cannot use these formulas because this is a special type of because over here, as you can see, so we are saying that 2 times tan inverse of x is equal to sine inverse of I'm sorry, no, not here, but what we want to show is that 2 times basically tan inverse of 24/7 is equal to sine inverse of 3/5. So in this type of problem, you cannot use this formula. This formula kind of applies to this situation, but you cannot actually use it because as you can see, I used the formula here and I got into trouble, right? So in this type of situation, what you can do is that you need to basically make some changes to that formula, and I don't really know how they have derived that for the changed version of that formula, but it doesn't really matter what they have done. At the end of the day, we know that there is this formula and we know that there is basically normally what we have here is basically 2 times tan inverse of x. We have 2 times tan inverse of x is equal to sine inverse of 2x over 1 plus x squared for basically the absolute value of x less than or equal to 1, right? And now you can make some changes to this formula and write it as sine inverse of a by b, I don't really know how they have actually found that formula, but sine inverse of a by b, you can write it as tan inverse of as tan inverse of basically a over the square root of b squared minus a squared, right? So you can use this formula. Now if I want to do this, what I can do is that I can simply say that the LHS of this let's call it 1. The LHS of 1 basically is 2 times sine inverse of 3/5 is equal to 2 times. Now sine inverse of 3/5, I can, based on this formula, I can write it as the tan inverse of I can write it as 2 times tan inverse of, so based on this formula, the sine inverse of 3/5, I can write it as the tan inverse of, so over here basically a is equal to 3 and b is equal to 5. So over here I have 3, the square root of basically 25 minus 9, and 25 minus 9 is equal to 16. So this becomes a square root of 16, which is equal to 4, which is equal to tan inverse of 3/4. So sine inverse of 3/5 is equal to tan inverse of 3/4. So I can write this 2 times sine inverse of 3/5. I can write it as 2 times tan inverse of 3/4. That is basically that, right? Now 2 times tan inverse of 3/4, I can write it as we had a formula before that, which was basically 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared, for basically -1 less than x less than 1, right? So 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared. So I can write this as basically tan inverse of basically 2 times 3/4. So that would be 2 times 3/4 divided by 1 minus basically 3/4 squared is 9/16, which is the same thing as 3/2 over 1 minus 9/16 is equal to 16. 16 minus 9, which is equal to 16 minus 9 is equal to 7, right? 7 plus 9 is equal to 16, right? 16 minus 9 is equal to minus 10 is equal to 6, minus 9 is equal to 7. So that is 3/2 over 7/16, which is the same thing as 3/2 times 16/7. Now this becomes 8 24/7, right? So that is the tan inverse of 24/7, and that is incidentally equal to the RHS. Tan inverse of 24/7 is equal to RHS. Therefore the LHS is equal to RHS, and so the identity is proved. So that is basically that. Now the the next question that we have here is question number 4. Is question number 4, which is sine inverse of 8/17. Sine inverse of 8/17. Plus the sine inverse of 3/5 plus the sine inverse of 3/5 is equal to the tan inverse of 77/36. So let's see how we can solve this problem. Okay, so now in order to solve this problem, we need to take a look at these formulas, and you want to prove that basically that this is the case. And so you have basically two sine inverse added together, sine inverse plus sine inverse, and that is equal to 1 tan inverse. So let's see. Okay, so the way that you can solve this problem is, again, you need to use the formula that we had, that we don't have it here actually. The formula is sine inverse of A by B. This was question number 4 actually, right? This was question number 4, I suppose, right? 77. Okay. Now, you know that basically the sine inverse of A by B, is equal to tan inverse of A over the square root of B squared minus A squared, right? So to use this, I can write the sine inverse of 8/17. The sine inverse of 8/17, I can write it as the tan inverse of 8 over the square root of 17 squared minus 8 squared. 17 squared minus 8 squared. Now 17 squared is the same thing as 49 4 and 11 0 17, so that's 9 8 289. 17 squared is equal to 289, right? And 8 squared is equal to 64. 8 squared is equal to 64. Now 17 squared minus 8 squared is equal to 289 minus 64, which is equal to 225, which is equal to 15 squared, I think. Which is equal to, I suppose, 15 squared. So 225, well, or 15 times 15 is equal to 225, right? So basically then this whole square root function and everything that it contains, it becomes basically 15. So you can write this as the tan inverse of 8/15. 8/15, right? Now the sine inverse of 3/5, you can write it as the tan inverse of basically 3 over the square root of 25 minus 9. 25 minus 9, and so this is the square root of 16, which is equal to 4, so that's the tan inverse of tan inverse of 3/4. Tan inverse of 3/4. So now we have another formula. We have another formula which is the tan inverse of x plus the tan inverse of y. We have the tan inverse of x plus the tan inverse of y is equal to basically the tan inverse of x plus y over 1 minus x times y. X plus y over 1 minus xy. So basically now the sine inverse of 8/17 plus the sine inverse of 3/5. So now the LHS of 1, for example, if I call this 1, the LHS of 1 becomes the sine inverse of this plus the sine inverse of 8/17 plus the sine inverse of 3/5 plus the sine inverse of 3/5, which is the same thing as the tan inverse of 8/15 plus the tan inverse of 3/4. And based on this formula, this is equal to the tan inverse of 8/15 plus 3/4 over 1 minus 8/15 times 3/4. Now you can basically you can write this as 5 and write this as 2, so that's 1 minus 2/5. 1 minus 2/5. Now let me calculate this here. You have 8/15 plus 3/4 over 1 minus 2/5, which is equal to basically 15 times 4, which is equal to 60. 60 divided by 15 is equal to 4. 4 times 8 is equal to 32, plus 15 times 3 is equal to 45. And 1 minus 2/5 is 5/5 minus 2/5, which is equal to 3/5. So that is 3/5 there. And then you have basically 32 plus 45 is 77. 77 by 60 over 3/5, which is the same thing as 77 60ths times 5/3, and 12 times 5 is equal to 60, so that's 77 by 36. So that's the tan inverse of 77/36, which is equal to the RHS, and that way we have solved the problem, right? So that is question number 4. Question number 5 is the cos inverse of 4/5. Question number 5, you want to prove that the cos inverse of 4/5 plus the cos inverse of 12/13 is equal to the cos inverse of 33/65. So here there is another formula that you can use. So I'm going to write the formula. I'm going to actually, I had a sheet that contained these two formulas. Let me find that sheet. Okay, so there is another form. So first of all, there was the formula that we used in the previous exercise, I think, and that is basically the cos inverse or the sine inverse of A by B. So that was basically the sine inverse of A by B is equal to the tan inverse of A over the square root of B squared minus A squared. That was one thing. Now, of course, I'm going to add these to the formulas that we have, and then at the end you are going to get all of those formulas, the additional ones, as from me. The second formula that is in the form of these ratios is the cos inverse of A by B. The cos inverse of A by B is the same thing as tan inverse of the square root of B squared minus A squared, over A. Right, so now what I'm going to do is that I'm going to end this video here, and we will continue this in the next video. Thank you.